Hello, everyone. We're working through Statistical Methods for Rates and Proportions, Chapter 11, Section 3, Part 2, Multiple Binary Logistic Regression, Additive and Interactive Models. All right, in this section, we are now going to think about a logistic regression model where the outcome, Y, has two outcomes, and we usually designate this in R with a 0 or a 1. Where 1 is considered the success that we're looking at and 0 is failure. And now we're extending it using equation 11.15, that instead of just having one variable, you can have multiple variables. All right. When we are in a situation where we just have no interaction terms, right? And in that case, the explanatory factors are each individual independent variables, then that model is going to be said to be additive, okay? Whereas when we have a model with interaction terms, right? Now that is going to be called an interactive model because it includes interaction terms. Okay, so just wanted to get those definitions out there before we started on this code. What we're going to do is we're going to do something very similar to last time. We're going to build out table 11.1. And just as a reminder, that is on page 293 of the textbook. All right, so we're going to create our data set by making our table. If we look at this, okay, and now I'm going to create my data set by using this cbind function, and then outside of that cbind function, I'm going to create a data frame using as.dataframe. If I look at my data set, it's very similar to table 11-1. So I'm going to do a similar thing to get the rest of the variables that were in table 11-1. And I'm going to get the total number and the proportion of trisomy karyotypes. Okay, I'm going to create a list and I'm going to make the long form of this table, just like we did in chapter 11, section 11-3-1. Okay. And then I'm going to use this do.call function, and I'm going to say, put everything on that list in rows. That's why I'm using the rbind, and then create a data set called temp. So from here, I'm going to expand what we have to follow table 11.2. That's on page 299 of the text, okay? And in table 2, you'll notice that there is an additional X value besides age, and that's smoking status, right? So what we're going to do is we're going to create a binary variable for each of these: current smoker, ex-smoker, non-smoker. All right, so let's just take a look at the first 10 rows of temp to remind ourselves what our data set looks like. Okay, so right now we just have the X and we have the outcome of whether or not there's trisomy. Okay, we're going to now create the current smokers, ex-smokers, and non-smokers. And what I've done here is I've used the repeat function, REP. And if you look at table 11-2, there are 5 current smokers who are aged 15 to 19. That corresponds to an X of -2.5. And then there's 0 ex-smokers, and there's 4 non-smokers. So essentially for current smoker, I'm going to make it a 1 for the current smokers, but then I'm going to make it a 0 for the ex-smokers and a 0 for the non-smokers. Similarly, when I code the ex-smokers, I'm going to code a 0, a 1, and then a 0. And for the non-smokers, I'm going to code a 0, and a 1. Okay, so let's run all of this and then look at the first 10 rows of the data. Okay, great. So, right, we had for an age of -2.5, trisomy, yes, so a value of 1. And then current smokers, there should be 5, right? So if we look at this, that's why we have 5 ones under current smokers. Then if you notice, we should have 0 rows in that same scenario with ex-smokers, and we did. And then we should have 4 non-smokers in the same exact situation. So I just wanted to verify that the long form of the data that we've created actually does correspond to table 11.2. This can be tricky to do, but you get used to it if you write it out. It takes a bit of practice. All right, so in the additive model that we're doing, essentially what we want to do is we want to fit a GLM model. We could have called this anything, but I just called it fit.glm.additive. And we are now going to look at our outcome variable. And we have an X1, which was the age. And now we also have the X2 and X3, right? Current smoker and ex-smoker. Now, we should note that we're not going to include the non-smokers here, because once you know the answers to being a current smoker or being an ex-smoker, you know whether or not you're a non-smoker. So if you were to add in non-smoker here, you'd actually create a singular model and it won't estimate the non-smokers. So it's just good to note that you only need 2 of the 3 indicator variables. So if your variable in this case had 3 levels, we just need to create 2 indicator variables to put into the model. All right, we are once again doing logistic regression. So the family should be binomial. And at the end of the day, we can get a summary of our model. Okay, this is looking fantastic. So we have our coefficients here. We have their associated standard errors, the test statistics, and the p-values, right? So if we look at this and we look at table 11.3, you'll notice that these values match up to the second portion of the table where you have beta 0, beta 1, beta 2, beta 3. And then you have the estatiments of those. Okay, so negative 1.128, looking good. 0.330504, negative 0.3393, and negative 0.0668. So this is matching up exactly what the text gave us. And so we feel really good about that, having it all built in. Okay, we can fit an ANOVA of that fit.glm.additive. And when we do that, we can get the -2 times your maximum log likelihood. There it is right there, 749.35. All right, notice these are added sequentially from first to last. So that's how you know that you're going to take the last thing, because that's putting everything in your model in. You get your -2 times your maximum log likelihood when you get to the very last row. Okay. Similarly, we would like to fit an interactive model, right? Okay, so how are we going to do that? All right. We can say now we want to have an interaction term. So we have our y value, we have x1, we have x2, we have x3. And then I'm using this colon because I want an interaction term between x1 and x2. And then I want an interaction term of x1 and x3. Okay, once again, still logistic regression, so the family equals binomial. All right, so we fit our interactive model and get the summary. And what do we have here? Okay, we have the top of table 11.3, right? And if you double check all these coefficients, it matches what's in the textbook along with the standard error, right? And the z-value. Okay, the book doesn't give the p-values, but R does. So these are the p-values associated with each of those coefficients. We can see that we could just look and see, oh, there's our residual deviance, 743.12. Or similarly, if you wanted to do the ANOVA, you could see that it's right there at 743.12 as well. So it just depends on which way you want to go and find the -2 times your maximum log likelihood. Either place you can get those values. All right. And if you notice on the bottom of this table, it says the joint test of significance of the interaction terms. That's really saying, should I include both these interaction terms or not?